Hello guys, so today we are here to solve our daily lead code challenge. This problem was asked in one of the previous days, and this problem is about find lucky integer in an array. Okay, so in this, given an integer array of integers R, a lucky integer is an integer that has frequency in the array equal to its value. Okay, return the largest lucky integer in the array. If there is no lucky integer, return -1. So obviously we have to use a map, but the condition of the array is that the ith element of the array can only be in between 1 to 500. So instead of using this map, what we can do, that we can create an int itself and use it as a map. This int will be of size 501. Why 501 and why not 500? Because even 500 is there as part of this. The number 500 can be part of this array, so that's why we need the range of the array should be in between 0 to 500, and 0 to 500 is 501 slots. So that's why we are initializing our array with size 501. Now we will go through these elements of this given input array. Okay, and then map of I will increment the map of I. Afterwards, what we will do, that we will go through the elements of the array and see, return the largest integer in the array. So that's why we are starting from the index I is equal to 500. I is greater than 0. Okay, and here what we will do, that now we will use if map of I is equal to I, then we will return I. Otherwise what we will do, we will return -1. So this is as simple as the solution can get, and we expect this solution to be working fine. So let me just submit it. It should run fast, rather it should run the fastest. But we can see that even though the solution is fast, it's not the fastest. What can we do to make this solution even run even faster? So to do that, what we can do, that we can make this as static. Okay, and then create one static block over here. In this static block, what we'll do, that we will create a for loop, and here we will call find lucky and just pass one empty array. And here what we'll do, if return -1. Okay, so we'll just run this. Okay, perfect. So now we are able to make this solution run the fastest. See, this trick is necessary to help us in optimizing the JVM generated bytecode. By invoking find lucky 100 times in the static initializer, see, we are invoking the function find lucky 100 times in the static initializer, times in the static initializer, we force JVM to treat find lucky as the hot method. Okay. So what is hot and what is cold? Any method which executes for a given value which is more than the threshold, then it is regarded as a hot method. And at the class load time itself, we are calling find lucky from the static initializer block 100 times. So JVM treats find lucky as a hot method, okay, right at the class load time. And this triggers hotspots tired just in time compilation. So first it goes to the C1 compiler, then it goes to the C2 or Graal compiler. And when it invokes C2 or Graal compiler for the hot method, then all the downstream optimizations like bound check elimination, loop unrolling, inlining, register allocation, etc. Uh, you know, happen. Okay, so that when you later call find lucky for real, it is already running as a highly tuned native code and thus executes faster by a constant factor. So this we have to understand and use it in our solution. With this, I'm thanking you. Thanks a lot. Happy coding. Best wishes.